But let's kick off then. Hello, everybody, and who has joined us. Welcome to our webinar called Creating a Competitive Advantage Through Smart Batteries in Uncertain Electricity Markets. Just as a short introduction, my name is Jan Tiemann. I am the Marketing and PR Manager at Fusebox. And together with me today are Dr. Olle Jakob Sördalen from Pixii, our Norwegian partner who is designing and manufacturing and selling energy storage solutions. We have Otto Perl from Fusebox, our CFO. Fusebox, for those who don't know, is an Estonian green tech company that has developed a fully automated battery management software. And also we have Erik Tammsalu from Fusebox, our development manager. And as a surprise guest, we have people coming in from Hoidema. Hoidema is the installation partner for Fusebox, and they have decades of experience in the field of installing and technical system management. And they are here today to give some tips about how to install battery systems. If you haven't noticed, then we are recording the webinar. The recording will be made available for you in the coming days. And it will take about 45 minutes for the presentation. You will have some time to ask questions after that. In order to ask questions, you can click the Q&A button at the top. You should be able to see it. And just write the question there, and we'll get to it then after the presentations are finished. But I will now pass the microphone over to Otto.
Good morning. So let's kick off with a official part of the webinar. Just who doesn't know, Pixii and Fusebox started the cooperation actually under a facility by Norway Grants and the EES, which financed the initial installations of the battery systems in Estonia and Finland, and also the development of cooperation. And as far as we know, this is one of the more successful, or not, if not the most successful, Norwegian cooperation to date under this program. Now to the background. Why storage, why flexibility is actually needed in the market? We basically are experiencing a confluence of factors and shifts in the environment that are necessitating grid balancing, because due to a number of different factors, political, technological, and fiscal, we are moving towards a intermittent energy production coupled with a increasing share of electricity in overall energy consumption. And that creates an environment where we do not have the same stability in the grid that we used to have with fossil fuel production, basically creating a strong baseline, and with that baseline gone, there's more and more need for energy and electricity balancing, and that can come basically from two sources: a combination of production and consumption flexibility and energy storage. So just in a nutshell, basically the solution is either to go with the historical way of operating things and build more very CO2 and fossil fuel intensive base production facilities that can help us balance the grid, or we can go with grid balancing through smart grid and investments into energy storage. We as Fusebox, of course, are the proponent of the latter or the Fusebox approach, and today we offer opportunities for businesses to have solutions from both sides, flexibility, demand and production side, flexibility and energy storage. But today here, we're talking about energy storage as the main topic of today's conversation. What would energy storage look like in a very demanding environment? Is that energy storage connected straight to the grid is quite simple. You basically use that to optimize or make money with the shifts in energy prices, but a lot of our projects actually take place either at the consumption or production sites, and there you are bringing together different pieces of the environment and industry to make the grid smart, and everything is facilitated by a smart grid operating software, which we are supplying to our customers and partners. A good example here is a project that we have ongoing at Tikupois, and maybe Erik can a couple of words later on, but there we're basically bringing together renewable production at Tikupois. Who don't know Estonia, it's a I would say a very interesting concept of the next generation gas station within Estonia, which uses or offers EV charging. It has its own shopping area, and it's smack in the middle of the country where you are most likely to run out of gas or energy during your trips. And they have their own renewable production with solar and wind, actually. They also offer EV charging on location and consume most of the energy actually on location. But there again, you need time shifting of the energy production to match the consumption. You need to optimize your metering point of contact to the grid, because that's always limited, as most of us know well enough, and maximize the production on site. So that's basically the project on the more difficult end, where we're dealing with all the assets and bringing it all together on a smart grid basis. Today, Fusebox is operating in 4 markets, in the Baltics and Finland, but we are already active in additional markets where we expect to also be integrated into the TSO network, which is integral and needed to be able to bring more value to the battery owner. And we discuss this a little bit later, what it means to have access to ancillary markets and not only be dependent on spot price shifts and when operating a battery-based asset. But as you see from the map, we are expanding fast. I'm here to announce also that we just closed our last round of financing as of yesterday, and we have brought on a very strong strategic partner in energy company from Netherlands, and also a financial investor from Poland. So we expect to have a very interesting couple of years ahead of us with the expansion plans into the rest of Scandinavia and also Western Europe. So again, before I hand it off to our partner in Norway, I would like to remind you that Fusebox is a platform operator. It's a software based approach and cloud connected platform that we offer to all our customers. We optimize the use of assets, be it batteries, be it your buildings, and related to energy efficiency and also making money from the ancillary markets. We offer our customers all the benefits of having online and real-time access to your assets, together with our promise that we make money only when you might make money with related to the batteries, that if our fees are charged only on the net benefits versus a situation where you don't have a smart battery in place. So without further ado, handing it over to Ole.
Thank you, Atto. I'll show the presentations from my own screen. I'll just show how Pixii fits into this excellent cooperation. So Pixii, we are a technology developer of energy storage, and as you have seen, the grid needs more flexibility, and energy storage is a very promising source for that flexibility. And what Pixii does is that we literally connect the flexibility source, namely the batteries, to the flexibility needs the grid. And we do that by developing power converters. So that's the power electronics, converting AC to DC and DC to AC. And we do that with a technology and a product called the Pixie-Box, 3.3 kilowatts, a bidirectional battery inverter with lots of features and functionalities inside. So that is one of the components. And in our concept, we dimension the capacity in terms of power by inserting a number of these Pixii boxes. And one Pixii box, again, it's 3.3 kilowatts. There is space for 3 of those across in a 19-inch shelf, and it's a so-called 1U high, so about 4.5 centimeters high. So that gives you an idea about the dimension here. So by inserting a number of these Pixii boxes, you get the power capacity required for a system, including both these power converters as well as third-party batteries, typically lithium-ion batteries. And in our case, we connect them in parallel, 48 volts. And with that, we can put them into systems. For example, this about 2-meter high fridge size cabinet, outdoor cabinet, to have a pre-wired modular and scalable energy storage systems of a certain capacity, again, given by the number of Pixii boxes to give the power capacity, and then the energy capacity that depends on the chemistry of the batteries. Either you have a power-oriented battery or an energy-oriented battery. So from 50 kilowatt hours or up to 120 kilowatt hours. Another important component and technology into an energy storage system is the communication unit and application controller that we call the Pixii Gateway. That's also own technology. So this gives a pre-wired smart energy storage system of a configurable capacity. If you need more capacity than this, what this cabinet can give, then in our case, you can connect them in parallel. We also have a solution then with a pre-wired, pre-installed concept with 12 of these systems and also an installation or a power cabinet on a 20-foot container base. So you can have up to 1.4 megawatt hour on such base. And if you need even more, then you could install several of these in parallel. So that is the modular and scalable concept of Pixii to have an energy storage system. Where are these systems then installed? Well, you need flexibility all around in the electricity system, because you could have two types of imbalances. One is the temporal imbalance, meaning an imbalance between the production and consumption at every instant in time. But you could also have a spatial imbalance that leads to congestions and voltage problems. So energy storage systems could be located both on the generation side, along on the distribution grid, or behind the meter at various type of customers like residential, commercial and industrial, telecom, EV charging operators we see an increasing interest from, and also what we call the communities and community energy storage. So that's where you could find the distributed energy storage systems. And then I will just go through some typical examples of how you use this energy storage system, because it's a very interesting multi-tool that could solve several of the various flexibility needs in various time scales. So a typical example we are seeing now is that you have say a petrol station or a restaurant that have had their grid connection capacity, but now would like also to offer energy storage or EV charging to their customers. But they realize that their grid capacity is limited. So to overcome that and give a proper EV charging capacity, an alternative to wait long time and to upgrade the capacity from the line, if you can get access to that, is to use an energy storage as a power booster. If you have that flexibility, then you could of course also use that for harvesting surplus locally generated power from, for example, solar panels. You could also use it for tariff optimization, time of use, and also peak shaving for demand charges. But you could also use it not only then to get increased power capacity and reduce on your electricity tariff, but you could also sell that flexibility during times when you don't need that power capacity yourself to various markets. So you see, it's a fantastic multi-tool with a lot of applications, and the fact that it can also then be used for selling flexibility, that's a bridge to then Fusebox, who would be able to play that role to aggregate these kind of distributed resources to make sure that this flexibility gets a value in different types of markets, either energy markets or ancillary service markets. Okay, so then back to you, Fusebox.
Thank you, Ole, for that good overview of the Pixii energy storage systems. So pretty much, if you already have the hardware, then the majority of the Fusebox value lies in the possibility and capabilities to operate your energy storage systems, and not only to store the energy when it is cheap on the market, but also generate you a new source of revenue through the ancillary services such as FCR markets in the Nordics or MFRR markets in the Baltic states. And this is extremely important because usually smaller distributed storage systems cannot participate alone in those markets. So what Fusebox does is combining pretty much distributed storage systems all together to place them on the markets as a one bid. Then in addition, there's obviously the reduction of the cost of energy through using or storing the cheaper electricity during the night hours, for example, or storing the local energy you actually produce through your wind generators or hydro or
or PV, and to utilize the stored energy during the more expensive hours, which also actually reduces the stress on the grid and reduces CO2 emissions on an energy system scale. And all that together combined actually leads you to a better return on investment. So the main two main use cases we see today in the markets we are active, so it's mainly Scandinavia and the Baltic states, are when renewables such as PV, hydro, wind are combined with energy storage or batteries. And in that case, first of all, you can avoid like a grid concession if you don't have enough grid connection point capacity. Then there's definitely a big thing coming in the Baltics, like a PV cannibalism. So you can store your energy throughout the day when the prices are the cheapest to actually get more money out of your production. And in addition, in these areas, in these markets, in the Scandinavian and the Baltic state markets, you do only have PV around 20% throughout the year. So the grid connection point, which is super valuable asset these days, is underutilized massively. So adding storage will grant you the access to additional revenues even during the night hours or for the winter period. And the other main use for the battery energy storage we have seen so far is combining the energy storage with a consumption site. So it's either it's a shopping mall or as Ahto brought out, a gas station or a factory. So everybody wants to optimize the cost of energy these days to actually utilize the better prices throughout the nighttime and lower your average cost of energy. And also you can combine it with local production as well. So a few examples, what are the estimated earnings from the markets Fusebox is active in? The main differential on this picture is the Baltic states tab, because in the Baltics we do not have, let's say, reserve power markets. We only do have energy-based balancing markets. That means the number seems really big, but it is also based on a 2.5 hour battery. That means you also pay more for the storage capacity. However, as you can see, the most attractive market today probably is Sweden, but we can see also really positive trend in both Finland and Denmark, where the ROI numbers are pretty attractive as well. Since the beginning of this year, where we started with our first pilot site with energy storage, I think today there's more than 10, definitely even more than 15 sites under the operation of Fusebox in several countries, and I think that's it from my side.
Right. I'll finish off on the financial discussion and the ability for storage systems to support your existing assets or to be a standalone investment, with the importance of having the storage system available for ancillary energy products. And ancillary energy products are basically any other electricity market revenue stream that could be accessible beyond call it the spot price optimization. And with regards to the slide where we discussed the country differences, it's also important to note at this point there are more products available for energy storage systems in Scandinavian markets, as we can safely say that they are more developed with regards to different ancillary products. And this is definitely coming to Baltics and other lagging markets as well, as the need is there. And in Baltic case, the interesting year is 2024, when we're expected to disconnect from balancing from by our eastern neighbor. So that's a benefit of owning an asset that's already proven capable of offering these kinds of I would say frequency-related services in the market, which Pixii has, and we together with Pixii are actively participating in these markets already in Finland, for example. So just to highlight why ancillary markets are important is on this slide. Basically, this has 1 week worth of battery activity in September, and this battery has through Fusebox access to spot market optimization and also COBA market, which is the MFRR product available for batteries in the Baltics. And here you can see the price differences both on up and down regulation. The blue line is basically spot market pricing, which would mean that if you activated your batteries charges and discharges only based on spot market, this battery would have seen 7 cycles or 7 full discharges during this 1 week 1 week time. But this battery also had access to COBA and made 11 cycles in a week, which is more than one per day, and also increased the revenue, the cash flow opportunity by a multiple, because it was able to unlock the prices that NPS didn't offer. So, for example, NPS pricing in this week was at maximum 600, but in COBA market the same battery could earn excess of 1,000, which is additional cash to the system owner. And this basically illustrates the need for anybody investing into storage systems to investigate whether that storage system is capable of participating in these markets, and also consider the up and coming potential markets down the line. But in order, and why we also decided to involve a third party here in the webinar is to highlight the importance also of the process itself, both pre-investment decision and post-investment decision. And for this, I would like to hand it over to Hoidema and to discuss a little bit what the general steps are before making a first trade and after that. So please take the floor, Janor or Andres.
Hello. Thanks, Otto. Great to be here. I really appreciate. I'm Andres from Oide, and together with Jan, we will walk you through a quick implementation process of battery. As Jan mentioned, we have decades of cumulative experience in the field of hydro energy and solar, but batteries actually makes us really interested and I think excited. So let's go through what it takes to make battery installed. So maybe I will. Jan, are you here?
Yes. Okay. Hello and good morning, everyone. My name is Jan Niilo, and I'm from Hoidemaa side. And as already said, we are installing the battery systems to customers' energy system. So, yes, the goal is to connect the storage to the power grid, and that's it. Actually, it takes some more steps to take you to construction part and thereon to start trading. So at the first point, you will see in this side in this slide the points what it actually takes to even get to the physical installation part. So first of all, we will get the order from the client to connect the storage unit to the customer's energy system. And then we usually need to see the actual situation on site. Then we need definitely technical requirements from local network operator, and in some cases also technical requirements from local authority. Based on the information we collected from site, network operator, and from local authority, we will compile electrical construction project where we pay attention to different electrical parameters and safety. And in some cases, there is a need to apply for permission to start construction works from local authority. This part will depend, but as we have so short timeline here, then I will not stop for this point at the moment. And then if this paperwork is done, we will get to the point to start the construction, and that in broad sense means that connecting the cable to the storage cabinet or customer's power system. But this doesn't conclude the process yet. So next slide, please. Then we get to the construction. If the construction is done, after installation, there is a need to assess the installed system. This will be done by the certified third party. And after this document is issued, we can basically hand over the certified and working energy storage system. And in some cases, there is a need to request also the building permit from local authority. That's needed when there was a need also to request the permit for construction works. And so this is it. If this is done, then we can hand over the system, and customer will start working with this system. So next slide, please. If there is any.
That's thank you, Jan.
Maybe just to sum it up. Basically, we started together with Pixii and Fusebox already in January this year. So it's a kind of lengthy experience process. And I need to admit there are some details behind when it comes to, let's say, especially when it comes to any kind of fees paid by a system operator, for example, renewable support fees. So there are some specialities in each of the steps. So in case you would need some, detailed or have some detailed questions, we will take it offline or afterwards.
Thank you, Andres. Thank you, Jan. And basically, what companies like Hoidema are doing in this setup is supporting our client with the physical installation and the processes. We aim to develop a network of partners like Hoidema in each of our market to help those of you who do not want to do and deal with everything yourselves. Basically, what the process from Fusebox point of view looks like is we look at your site characteristics together with our partners. We would like to do it through our partners who are going to be your local support down the line, and that's why the aim to create a network of qualified partners. And the first step in our process is to dimension the battery in the right way. And as Erik mentioned in his slides, the battery dimensioning actually depends on what the battery is doing in a certain market. For example, if it's Sweden, it's more on the frequency end of scale that needs fast response. It's more about the power of the system. When you are talking about MFRR market in Estonia, for example, and you need to store energy to participate in these markets and actually deliver energy, that means a higher storage ratio to power is needed, and that's where Erik mentioned this 2.5 hour battery storage, which is not necessarily what we recommend for other Scandinavian markets. So this is done together with the client and our partner. Then we have our partners in actual representation of Pixii. We run double check the pricing with them, and we will help the client to get a all-in proposal from Pixii side. Then we help at times, and again it's as needed basis. We also help put together a financial forecast for the company to run through their internal processes, and from there onwards, when the decision is made, we will hand over the project mostly to our partners like Hoidema, and just the experience says, based on the current installation, is that it takes less than a couple hours to get the battery, once installed, participating in the markets already. So day one participation, so you don't need to wait until you get the integrations done, certifications with TSO, which might be the case if you're bringing to the market a battery that's has not been present before. And to cap everything off, is that we deal with the ancillary markets. We also receive the payments from the ancillary markets and actually help with the financial settlement of that. But the client itself has the electricity contract on location, and we combine that electricity contract details with the ancillary revenues, and that's the value optimization that we are bringing on. And as said, we only make money when our client makes money. So any net benefit left over after the optimization will be the benefit to the customer. So that's it from our end regarding the presentation. We can now turn to Q&A, go through those, and we will be happy to follow up afterwards as well. Should you have any questions remaining, just shoot us an email and we will follow up together with Pixii and our partners in place.
Okay, thank you for all the presenters and the presentation. And let's go to the Q&A. If you have any questions, then please click on the top. There's the Q&A button. Write it up, and we'll go through it as they arrive. So the first question comes from Mr. Tadas, and the question is, what is the capacity of the manufacturer in megawatts, the delivery time and installation time? So I guess this goes to you, Ole.
Yeah, so the capacity in our case, I'm not sure if they meant manufacturing capacity. That is quite high. Let me see what I could give of a number there. At least we could manufacture tens of megawatts per month that we have the capacity for with our subcontractors as well. So that is somehow not a limitation. We started with subcontractors that have that capacity, both on the power electronics manufacturing as well as on the system assembly. So that's tens of thousands of megawatts per month. That's the capacity. Delivery times could vary depending on some of the access of batteries and components, but typically 2 to 3 months could it be now, but it could vary. It depends. If you have it in stock, of course, it's days. If not, 2 to 3 months. Yeah, what were the other questions?
The installation time.
Yeah, installation time, yeah. I would say depending on, again, on the size. So say that you need to do some civil works, you need to, if it's an outdoor site, then you need to somehow prepare the ground, but it could be placed just on the ground, ensure that there's no risk of flooding there. But I would say one day or 1 to 2 days, but there maybe Anders and Jan could have maybe more practical input as well on how long time that would be. But the systems as such come pre-configured, pre-wired. So you need to connect the AC cable and Ethernet cable, and then just the physical installation and insert the batteries, because the systems are not transported with the batteries inside. But maybe Anders or Jan could have some comments to that.
Yes, exactly. It really much depends on a site readiness. In fact, 1 day would be sufficient to, make a physical installation. But if we, as Ola mentioned, we need to prepare the ground, wiring, and maybe the weather conditions actually vary. So that will all actually have an impact. But yeah, I mean, all in all, most likely 1, 2, maybe maximum 3 days would be sufficient, depending of course the quantity. If you speak 1 rack, that's one thing. If we need to install, let's say 7 or 10 racks in a same location, it will require connections in between racks. So, but all in all, let's say 1 rack per day would be the starting point.
And of course, Eric here can comment on how quickly Fusebox's software will start working once the installation is done.
Yeah, since we have like a manufacturer level integration with Pixii system, so whoever pretty much installs or commissions a Pixii battery system in the markets Fusebox operates, then it's around an hour or even minutes in some cases to get the site up and running and operational.
And just to comment on maybe on delivery times to Baltics right now, what we in Finland see is that if you put a firm order in today, you're most likely looking at delivery in call it Q2 next year. So so just to manage the expectations, but I can honestly say that this is by far the best delivery time available in the market for systems the size. Since Pixii's full supply chain is European based, it has always been a benefit from timing perspective.
So thank you. I think we have covered this question quite thoroughly. So the next question comes from Mr. Tadas also, and the question is how the battery storage. Oh, sorry. Yes.
Actually, I wanted to add some points to the installation part, because one part is a physical work which can be done really fast, and there's probably no problems. But another part is the paperwork what has to be done for this process, and there may be some delays because of local authorities or local network provider. This part we cannot predict how long this may take, because it depends on local authorities. So it may take maybe a month, maybe 2 months, or maybe 2 weeks even. So it depends highly.
And I think following up Jan's point is that the best way to do is to get started with this process in parallel when you are starting already thinking about installations, because that speeds everything up. So having a partner here is key with experience, who helps you minimize the potential of downtime after installation. So you're able to start using your system right away.
Okay, thank you. So the next question would be from Mr. Tadas about how the battery storage behaves in low temperatures. I think we have some empirical data from our side. Maybe Eric, you can comment on this.
Yeah, I actually wrote an answer as well. So there's a heater inside, and if the system is actually operational, then the temperatures remain really healthy. And what does that mean? It's pretty much that you could do more cycles within a day without exceeding, let's say, high temperature limits. However, I think Oleg can go more into detail regarding the characteristics of the batteries.
Yeah, that's correct, and it depends again on the chemistry. But typically for lithium-ion, as you understand, the apparent capacity goes down, and the power capacity goes down at low temperature. But as you said, Eric, in the case of Pixii systems, there is a heater inside as a default to manage that. So that's taken care of, and as if you use the batteries also actively, of course, that also helps to keep the batteries at a good temperature, say from 10 to 30 degrees, so 10 to 25 degrees, that would be good. But it's an issue on a personal level. Today I actually had to switch from a Nissan Leaf to take the diesel version to work today, because it's really cold now in Norway. So so that the Nissan Leaf didn't have a heater, so that's limiting the range. But in the case again of Pixii battery systems, there's a heater, so that shouldn't be a challenge.
Okay, thank you. The next question comes from Mr. Max, and the question is what we have already discussed, but what would be a realistic time frame from initial screening to when the client starts operating?
So yeah, just to take this first stab at it, I think the bottleneck in this process is having the delivery time set by putting the order in. So everything actually starts with decision making on the client point of view, and right now, as I mentioned, Q2 deliveries are doable. Just need to get to the decision and pre-order decision as fast as possible. And in parallel, you can already start on the processes that Jan was referring to, just to make sure that once the battery is here, it's all operational as soon as possible, after installation. But I would say that the key decision points are making the pre-order and by the customer getting to the decision of investment, and then putting the order in to Pixii.
Thank you. And the next question is from Mr. Tadas. The contract, is it done with the Fusebox only? I guess it boils down to who the point of contact is from the client's perspective.
So again, maybe to deal with it from Fusebox point of view, Fusebox is the software provider, and that's why we brought here both Pixii, who's the hardware provider, and also the one of the partners in the Estonian market who is going to be the project manager on site and possibly the turnkey solution provider. But here Fusebox has a service agreement after installation for services rendered on Fusebox platform, and we don't deal with hardware necessarily ourselves, and that's why we were building this ecosystem, making sure that we have all pieces covered, and so a potential customer doesn't need to start from scratch and dealing with everything themselves. But maybe Andres, Jan, you can comment also on how you would approach a potential client.
Yeah. Thanks, Atte. Basically, we deal the sales side, the sales support, physical installation, and all the contracts related to delivery side. So yeah, that in that sense, we actually have two contracts. One is related to physical delivery installation, and the other one which Otto mentioned in terms of further on operations and service offered by Fusebox.
Okay, thanks. And the next question comes from Max, and it is from the practical side. What are the key indicators in a property to look for with the battery solutions in mind? Is it the overall large consumption, big hourly differences in consumption from day to night, or something else?
Maybe I'll take a first stab as well, is that all these elements are part of the equation, and that's why I would say the initial assessment of the site and of the customer characteristics are important. Right now, we see that in all markets, battery is profitable with just grid connection, and so the first kind of element, if you don't if you're not able to consume everything on site, is having the grid connection. So, and upward grid connection, not just downgrade. And that starts all conversations, understanding what your grid connection looks like. Then we're looking at your call it production or consumption characteristics, and we propose a reasonable battery system based on your input and also your investment willingness in the first stage to propose a system that you can participate with. The good thing again, what we see with Pixii batteries is that it's a modular system, so you can start with a smaller system and build into a large installation. So that stepwise approach has been successful with a couple of our clients who want to get called feet wet with a smaller system and build into a larger one.
Okay, thanks. We have time for a couple of more questions. 2 minutes left. Mr. Artu is asking, was there an off-grid solution with the same battery system in case of a grid failure?
Yeah, I could comment on that. It's a relevant question. So the ones that we have delivered so far, they have been mainly grid tied. So it means they need to have a grid present in order to operate. Otherwise, they would act as a solar inverter. If the grid goes down, the inverters also has to go down. But as a matter of fact, we are actually now developing and launching also an off-grid variant. So a system could then disconnect from the grid in the case of a grid failure and then continue and operate in an island mode as well. First on a single cabinet level and then eventually with several cabinets in parallel. But that has not been the case for the ones we have installed so far. So those are meant for grid-tied operation.
Thank you. And Ole, I think the next question goes to you as well from Mr. Andis, and it is, what is the projected efficient lifetime for your batteries? And what about recycling principles after expiration of the efficient functioning of the batteries?
Yeah, so again, it depends on the use, but you could say typically the batteries would have around 3,000 full cycles. So with one cycle per day, approximately 10 years, that's the lifetime. When it comes to recycling, then at least in Norway, in Scandinavia, we use an organization responsible or managing the handling and recycling of those batteries. And in Norway, there is also a factory now actually doing the recycling to recapture valuable materials from these batteries. So all that's well managed in Europe, actually. So we are also contemplating of using repurposed electric vehicle batteries. Also, we have some pilots for that as well. But for the battery business now in Scandinavia and Europe, it's a well-established value chain for collecting and recycling lithium-ion batteries, as it has been the case for lead acid for many years.
Okay, thank you. But as our time is up, so thank you for your presentations. We can then, if anybody has any more questions, I see just one arrived, but yes, if you have any questions, then write us an email and we'll answer promptly. So thank you for joining and have a lovely day.
Thank you.
Thank
Bye-bye.
you. Bye.
Bye.